All right, so today we're going to go through section 1.3, which is about measuring segments. So for the length of a segment, you can always subtract the endpoints from each other. When you actually have a picture of a number line, it is a little bit easier just to be able to count. And so if I want to find the length of ST, that would be this length right here. What I can do is I can just go ahead and count each line or dash goes by 2. So I have 2, 4, 6, 8, 10, 12. I can do the same thing here. Find TV, that length right there. Again, I have 2, 4, and 6. And then what we should realize is that the length SV is this entire length all the way from S to V. And so I could count all the way there, but what I should also realize is that's just the purple piece and the green piece put together. And so SV ends up being 18. And that kind of illustrates what we're talking about down here. The segment addition postulate means the addition of the parts of a segment is equal to the whole thing. So just like we had in there, this piece AB plus this piece BC is equal to the whole thing, which is this AC right here. So that's what we've got over here with our formula. The purple piece plus the blue piece equals the green piece. And so down below here, we've got two separate problems, both using the same picture. And I think the important thing is for us to figure out, when I'm given a bunch of different parts, is figuring out which is the whole entire amount. So this entire length here from E all the way to G, that's going to end up being this 59 right here. So when I write it, I want to write it with letters first. So I'm going to put my whole amount, the biggest piece, EG, by itself, because I'm going to add the pieces together to equal that. On the other side, I then have each piece. So EF plus FG equals EG. Once I'm there, then I can go ahead and I can substitute in my values. So I can plug in EF as 8x minus 14. FG is 4x plus 1. And then EG is then going to end up being 59. I can combine my like terms. Get 12x minus 13 is equal to 59. I can add the 13 to the other side to get, let's see, 72. And then divide both sides by 12. And I'll end up with 6. Once I figure out what my x's equal, again, what I want to figure out is what are EF and FG. So I don't want to end right there. What I want to do is I want to continue on. So I'm going to grab my value for x, and I can plug it in here. And so I know that EF, so I do 6 times 8, or 8 times 6, minus 14. That gives me 34. FG, I can do the same thing. 4 times 6 plus 1 gives me 25. And again, my double check is that the two pieces add up to equal this entire amount right there. Okay. Same thing with the other one. I'm using the same picture. So the first thing I want to do is EG is my entire amount. So make sure that I identify my whole piece. So I know that EF plus FG is going to equal EG. I can then go ahead and plug everything in. So EF is 34, FG is 3x plus 1, and EG is 7x plus 7. I can then go ahead and combine my like terms. So 3x plus 35 is equal to 7x plus 7. I can subtract my 3x over to the other side to get 4x plus 7. Subtract the 7 to get 28. Divide to get, divide both sides by 4, and I end up with x is equal to 7. And again, I can do the same thing. I can plug in my values. So FG is going to end up being, let's see, 22. 3 times 7 gives me 21, plus 1 gives me 22. And then EG, 7 times 7 is 49. 49 plus 7 gives me 56. And again, the two pieces, 22 and 34, add together to get me 56. That's good. Last one, just vocabulary. So congruent segments. This is our congruency sign. Just know that congruent is the same thing as equal. Congruency and equality are the same thing that we're talking about. So when I use that congruency sign, I'm talking about, are they equal to each other? So our AC and BD congruent. Again, AC is 1, or sorry, each space is 2. 2, 4, 6, 7. And then BD is, so there's 1 is, oopsie. So 1, 3, 5, 7. So are they congruent? Yes, they are. They're both the same length. The other one is AB congruent to DE. AB is 2, 4, 5. And then DE is 2, 4. So no, they are not congruent. On the back side of the notes, so midpoint. And so midpoint, generally people can understand that the midpoint is the middle point of a segment. But what's the most important is that the midpoint divides the segment into two congruent segments. And so in the problem that I have right below here, Q is the midpoint. And so yes, Q is the middle, but what's more important for us is knowing that this segment here, PQ, is equal to this segment right here, QR. So I can put a single line through the segments. That is, in a picture, what shows that they are equal to each other. And here I can write that PQ, oopsie, is equal to QR. Again, that's something that I know because that's what midpoint means. Once I have those things, I have something to plug in for each of those values. So I get 6x minus 7, and QR is 5x plus 1. I can subtract the 5x to the other side to get a single x minus 7 is equal to 1, and then add the 7 to get x is equal to 8. I can then plug these back in. And so PQ, 6 times 8 gives me 48, minus 7 gives me 41. QR, 5 times 8 gives me 40, plus 1 is 41. And then the other thing I want to find is PR. PR is this entire amount. So again, it's going from here all the way to there. And so I add the pieces together to get that whole amount. So it gives me 82. The next part down, again, same thing. I'm going to mark on it if U is the midpoint. I can put 2 lines with 2 lines. Again, that's telling me that any segment that has 2 lines through it is going to be equal to each other. So TU is equal to UV. And again, I have something to plug in for each of those. So I can go 8x plus 11 is equal to 12x minus 1. I can then get my x's on the same time. I'm going to subtract the 8x over to the other side. So that gives me, 4x is equal to 11. Oops. Yep. And then I can add the 1 to get 12 and divide by 4. And that gives me 3. And then I can plug these in for x. 8 times 3 gives me 24. So that'll give me 35. 12 times 3 gives me 36. Minus 1 is 35. So that's good. They're both the same. That's the way it should be. And then TV, the entire amount, is going to end up being 70 by adding my pieces together. Last two examples are going to use the same picture, this picture that I have over here on the right-hand side. So again, M is the midpoint, so I can put a single line and a single line. So I know that AM is equal to MB. Those are the two pieces. And so what we need to make sure we understand here is, so I have this 8x plus 5 is what AM is equal to. But then be careful, this AB, that's not what I have over here on the other side of the equal sign. And so what we need to understand is AB right here is talking about this entire amount right there, the whole thing. So these two things aren't equal to each other. AM is just this piece right here. AB is the entire thing. And so if AB is the entire thing, I need to add together the two pieces to get the whole thing. And so I can have AM plus MB is equal to AB. Those two pieces add together to get me the entire amount. And so AB is 32. And then it should kind of make sense, since AM and MB are the same thing, that I can just double AM and that'll get me the entire thing. So I can just go ahead and put AM down twice, because AM and MB are going to be the exact same thing. I can then combine those together and then solve. So X is equal to 11. Some people, another way that you could do it is, if you know that AB is 32, if I cut that in half, that'll be AM. So I know that AM would be equal to 16. Then I could go from there. That would be another way of doing it. Last one, again, using the same picture. It's the same thing. I know that AM and MB are equal to each other. Oops. But again, the trick is that this AB right here, that's the entire amount. So that's the whole thing. So AM and MB are the same thing. They're both 21. So I could add them together, or I could double them, and then it'll equal the whole amount. So combine my like terms, add the 8 to get 50, divide by 4, and I end up with 12.5, I think. Yep, just like that. So making sure we understand our picture is really important for problems with midpoint, to make sure we know whether we have two pieces that are equal, or two, a piece and then the whole thing, where I have to do what I did with these bottom two problems.